All right. Looks like we're doing Algebra 2, 1025, 1026 today, OAS A2821. The student will factor a difference of cubes. Cubes are any terms that are multiplied by themselves 3 times. Here are some examples of cubes. If we said x times x times x, that would be x cubed. That means x multiplied by itself 3 times. 1 times 1 times 1 is 1 cubed. 1 to the 3rd power is cubed, equals 1. So 1 is a cube, or a perfect cube. 2 times 2 times 2 is 8. So 8 is a perfect cube. 2 cubed, 2 to the 3rd power is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 64. 4 times 4 times 4, 64. So forth and so on. These are cubes that you can expect to run into throughout the course of today's worksheet. X cubed, of course, and there may be a variable combined with a constant, both of which are cubes. But it's good to be able to recognize some of the more common cubes you'll run into. So I made a list of them here for you. 7 cubed is 343. So if you see 343, say, hey, that's 7 cubed, and just remember that. Just refer back to this. With all of this in mind, a difference of cubes, which is what we're talking about today, means that we're going to take 2 cubes and they're going to be subtracted one from the other, and we're going to factor that difference using a pattern. Just like, well, very similar to the pattern of a difference of squares. The pattern isn't the same, but it is a pattern factoring. So we're going to be factoring a difference of cubes. Here's the general case. If you have any cube minus some other cube, these can be factored as this times this. In other words, if I take A and distribute it, and then write all those down and take negative B and distribute that, and write all these down, and then combine like terms, all of the terms will subtract out. They'll be just disappearing left and right, except for A cubed minus B cubed. That's what will be left. If I multiply this times this, I'll get A cubed minus B cubed. So the factoring pattern, when I see this, is this. So I'm going to be appealing to this as I'm factoring differences of cubes. So here we go. This is the pattern that's in my head right here. And we're asked to factor differences of cubes. So I see, well, here's x cubed minus 27. Well, 27 is 3 cubed. So this, we can think of it as x cubed minus 3 cubed if we want to. I'm going to use this pattern right here. I'm going to say this will be equal to, here's how I do it personally. I open up a small parenthesis, and then I open up a longer parenthesis. And I place my plus and minus signs first. If this is negative right here, and the next 2 are positive. Now I've got 5 blanks. 2, 3, 4, 5. If I can figure out what goes in those 5 spaces, I've got it factored. What goes here is the cubed root of this one. For instance, the cubed root of 8 is 2 because 2 cubed is 8. So the cubed root of 8 is 2. The cubed root of x cubed would be x. If I took the cubed root, so what I'm going to do is put the cubed root of this one, which is x, right here, and put the cubed root of this one, which is 3, because 3 times 3 times 3 is 27 right here. And then we're done with this. To get these 3 blanks, here's what we do. We square this one, whatever it is, in this case it's x. Multiply these 2 together, forget the negative, because we've already pre-placed our plus and minus signs. 3 times x. Square this one. And don't worry about the minus sign. We pre-placed our plus and minus signs. And we're done. If I multiply this times this, I'll get x squared, x cubed minus 27. For this one, I'm going to go ahead and do that just to demonstrate that it will equal x cubed minus 27, but you won't be asked to do this. I'm just going to demonstrate that multiplying this times this mess will make a big, long polynomial, but everything will cancel out except x cubed and negative 27. So here we go. I'm going to distribute this. You don't have to do this part. X times x squared is x cubed. X times positive 3x is positive 3x squared. X times positive 9 is positive 9x. And then I'm going to take that negative 3 and do the exact same thing. I'm going to take negative 3 and distribute it. Negative 3 times x squared is negative 3x squared. Negative 3 times positive 3x is negative 9x. Negative 3 times positive 9 is negative 27. And I've finished distributing. Now, when I go to do all of the combination of like terms, I will see that this and this subtract out. 3x squared minus 3x squared is 0. This and this subtract out. 9x minus 9x is 0. So what I wind up with is x cubed minus 27. I'm just demonstrating that if I multiply these two together, I do get x cubed minus 27. All of these turn into zeros. With that in mind, I can say that the factorization of this difference of cubes is this right here. And we came up with this using this pattern. Okay? Let's do a couple more and I'll stop talking. I'm going to try to factor this difference of perfect cubes. This is 2x times 2x times 2x. And this is 5 times 5 times 5. So here we go. I'm going to use that pattern I demonstrated just a second ago. A small one and a large one. I'm going to pre-place my plus and minus signs. And then I just got to fill in these 5 blanks. This blank is the cubed root of this one. Well, this is 2x times 2x times 2x. So 2x. This is 5 times 5 times 5. So 5. Then we're done with this. We're just going to fill in these blanks in the following manner. We're going to square this one. 2x times 2x is 4x squared. We're going to multiply these two together, ignoring plus and minus signs because we pre-placed those. 2x times 5 is 10x. And then we're going to square this one. 5 times 5 is 25. And we're finished. Oops. All right. And that's how you factor a difference of cubes. You just appeal to this, which is what I just did. And if I multiply this like I did above, I'll get this. Everything will cancel out, except for the first two. All right, let's take a look at this one. I look at this and I say, hey, that's not a perfect cube. And neither is that. I gave you a list of common perfect cubes. And neither one of those are in there. So what I'm going to do is see if I can factor out a 4. And I can. This will yield x cubed minus, if I factor a 4 out of this, it gives me 64. So testing 4 times x cubed is 4x cubed. 4 times 64 is 256. So now I'm going to factor this different of perfect cubes and tag that 4 on the front of it. So it'll be 4, then a small one, and a long one. And so now I'm going to just factor this part. I'm going to pre-place my plus and minus signs. If this is negative, this one here is negative, and the next two are positive. And I fill in using the pattern. I take the cubed root of this one, the thing that's being cubed, that's the x. The thing that's being cubed here is 4. That's up here in my cubes. 4 cubed is 64. You just have to get used to those. Memorize them if you have to. So this is 4 cubed, so I'll just put the 4 here. Then I'm done with this part right here. And I can just fill in these blanks by squaring this one, multiplying these two together, and squaring this one. And I'm done. I factored it. I had to factor out a 4 first because I know, hey, 4 is not a perfect cube. So I factored it out. What was remaining is a difference of perfect cubes. So I factored this. Now I put the 4 there to indicate that I factored out the 4. And then this is the correct factorization of this resultant difference of perfect cubes. So there we have it. We're factoring differences of cubes. I worked 3 examples for you, and I demonstrated that this will indeed yield this, x cubed minus 27, and that will be the case every single time. if you were to multiply these. But all I'm asking you to do is factor them using the difference of cubes formula. You can do this.